Hello everyone, my name is Utkarshi Chauhan and in the previous video we had discussed about the knife based classification. Now in this video we will discuss about the neural networks. So neural networks are a powerful tool for machine learning and now we understand what is neural network. So introduction to neural networks. This is inspired by the biology. Like neural networks are inspired by the structure and function of the human brain and they consist of interconnected nodes that process information and similar to neurons. And this learning from data. Neural networks learn from the data by adjusting the connection between the nodes and they can learn complex pattern and make prediction based on the input they receive. And anatomy of a neural network. First one is input layer, second one is hidden layer, and third one is output layer. Input layer receives data which is then processed through the network, and hidden layer perform a complex calculation and transformation on the data, and the output layer generates the network's prediction or output. And then activation function and gradient descent. Activation functions and gradient descent. So activation function introduce non-linearity into the network, and gradient descent is a optimization algorithm that helps neural network learn by the adjusting the weights and the bias. And in the next, supervised learning with neural networks, training and prediction. Now we will understand with the help of code. So in the first step, we import the necessary libraries. We import the following libraries: TensorFlow for building and training the neural network, and matplotlib.py plot for visualizing the images and result. And in the second step, load the MNIST dataset. The MNIST dataset is a collection of 70,000 images of handwritten digits 0 to 9. And in the second step, we process the data xtrend and xtrend xtext is equals to xtrend images and labels used for training the model, xtext and ytext images and labels used for testing the model. And also processing the data, pixel value in images are normalized to the range 0 to 1, and by dividing 255 this helps the neural network train faster and a simple image is displayed to understand the data. And in the fourth step, we build a simple neural network model. Floating layer converts the 2D image 28 into 28 pixel and into a 1D array of 784 values. And the denser layer 128 neurons, a hidden layer using the ReLU activation, and the function it learns the pattern from the input. And the denser layer 10 neurons, the output layer using the softmax activation function, and it outputs the probability for each digit 0 to 9. And in the step 5, we compile the model optimizer. Adam adjusts the weights to minimize the error, and loss function is passed the categorical cross entropy measures the difference between the predicted and the actual levels. And the matrices accuracy show how well the model performs. And in the second step, we train the model. The model is trained on the training data, xtrain and ytrain for 5 iteration epochs. Each epoch updates the weight of the model to reduce the errors. And in the second step, we evaluate the model. The trained model is tested on unseen data, xtext and ytext to calculate and then make prediction. In the eighth step, the model predict label for test images. We visualize the few test images along with the predicted label what the model gives and actual label the correct digits. And for visualization, some prediction, we just write these all are, and the output of this code, this is the output of this code. So this model achieves around 98% accuracy on the test set, and you see 9 images. You see 9 images with their predictive and actual levels displayed. These step-by-step approaches demonstrate how neural networks can classify handwritten digits effectively. I hope you will understand this video. Thank you for watching my video.